All right. Fundamental Theorem of Calculus, Part 2. We did it past 2 days. It's the most popular part, the integral from a to b of f of x dx is equal to f of b minus f of a, given f is any antiderivative of little f. We've done that the past 2 days. You should be really good at it with your practice. Take an antiderivative, plug in the top, plug in the bottom, subtract. You're done. Gives you the exact area bounded beneath the curve in the x-axis. I mean, it's incredible. Changed the world forever. Okay, the ability to take a derivative and the ability to do an antiderivative, evaluate it, truly did. The way the technology changed after that point and our ability to engineer different things and understand the world changed forever. So this is talking 1600s when we were able to formulate this, 15 to 1600s, right in that area. Part 1 is less known. Part 1 says if f is continuous on AB, what does it mean f is continuous on AB? What's f? What do you think f is? Rhymes with unction. It's a function. There you go. So we got f. Continuous on AB. What's AB? That's your interval. It says let g of x be the area function. So g of x is an area function. It's equal to the integral from a to x of f of t dt. So the definite integral can be written literally as an area function. What's really cool about that is when you take the derivative of this area function here, anybody know what you get? You get the function up above. Instead of t, you have x. The derivative of the area function is the function that bounds it. Now, this is definitely more of an AP idea than it is a traditional calculus topic that's covered. It's very important because sometimes people skip it. They go right to Fundamental Theorem of Calculus Part 2 because it's used all the time. Part 1 is important, yeah. So flip to your back page and I'll show you how it's new. And this should be x. We're going to get to the front side in a second, but instead of t, it should be x. Sorry, Adam. I'll use kid terms from now on for you. All right. So, if I have, just to be clear, if I have x to the fourth is equal to 80, how do I solve that? What do I do? I take the fourth root because you know and you understand that the fourth root and the fourth power, those are inverse operations of each other, correct? They're inverse operations. So if I write this, sine of theta is equal to 1/2, how do you solve for theta? What do? You do the sine inverse of both sides. And that way those go away, and you end up with theta is equal to that. What if I have this? What if I have 2 to the x is equal to 40? How do I solve 2 to the x is equal to 40? Log base 2 of both sides, because those are inverse operations. Well, guess what, folks? These are inverse operations. That and the derivative are inverse operations. So in other words, if you take the derivative of this, you just end up with the function. This right here makes this and this go away. They're inverse operations of each other. This means antiderivative, this means derivative. They undo each other. So if you see this question on the AP exam, it looks extremely difficult. G of x is equal to the integral from x, or 0 to x, of the root of t plus 3 dt, and it says find the derivative. So g prime of x is going to be equal to, if I take the derivative, I'm just left with the function, and I plug in the x. That's it. So when you take the derivative here, and you take the derivative of this side, the dt and the integral goes away. You're left with the function. Okay? You'll see what comes up when we move the x around, and you'll see why we use the different variable in a second here. So if I take the derivative of g, what's the function? 3x squared secant of x. That's it. That's the answer. Now, D. Weiland, do you know what people do on the test here? They actually take the derivative of this and they use the product rule. People make this way more confusing than what it needs to be. You see why they might do that? Oh, wait, take the derivative. Okay, I got to take the derivative of that. And when you take the derivative of the area function, the integral and the dt goes away. So now, what do you notice is different about this problem? X on the bottom. Part of the fundamental theorem of calculus is that we integrate from left to right. And if you switch it around, if you switch it, it becomes negative. So we're going to switch this. We're going to say g of x is equal to, we're going to rewrite it, integral from 6 to x of negative sine of t squared dt. It doesn't do anything in terms of reflecting. It's just saying that when you integrate right to left instead, it makes it negative. There's not really a good geometrical representation of that. If there is, I'm not really aware of it. I'd have to look into it more. And again, when do you ever see that? Really only on the AP test. Very isolated situation. So when you take the derivative, g prime of x is equal to negative sine of x squared. So how would I rewrite the next one? G of x is equal to integral from 3x of negative natural log of t dt. So now I'll take the derivative. And I get negative natural log of x. A lot of people take the derivative of negative natural log, which would be negative 1 over x. That's what a lot of people will write on the test. Don't do that. That's the second derivative. That's g double prime. Don't do that. Okay, what's different about this one? Yeah, I got the 2x cubed. So I'm going to change this a little bit. I'm going to rewrite this. I'm going to write this as the integral from 1 to u of t over t squared minus 1 dt. That's my outside function. My inside function is 2x cubed. I have to use the chain rule in order to find the derivative of this one. So, right, this looks like, on the AP exam, this would look like an extremely challenging question. The fact is, if we just set it up right, it's really not that bad at all. 2x to the third, what's the derivative? 6x squared, what's the derivative of this? Okay, Austin, you're right that you're going to leave this, but you have to plug this back in. Okay, so it's going to be u over u squared minus 1. And so this will be plugged in for u. So 2x cubed over 4x to the 6th minus 1 times 6x squared. Total of 12x to the 5th over 4x to the 6th minus 1. that. And that's just really what it's telling us. You know, we're just applying the rule. So now, last type of problem. This would be, I guess, I would say this is the content limit for what you would have to know for this type of problem. First of all, I'm going to switch it. G of x is equal to the integral from 2 to 1 minus 4x of the cubed root of sine of t dt. So all I did is I got rid of, I switched the bounds, and when I switch the bounds, it turns from positive to negative, negative, positive. Because I have a 1 minus 4x and not an x, I need to set up the chain rule. So on the outside, I have 2 to u of the cubed root of sine of t dt. What is u? What's the inside? What's the derivative of 1 minus 4x? What's the derivative of the integral from 2 to u of the cubed root of sine of t dt? Good. The cubed root of sine of u. So I'm going to plug the 1 minus 4x in for the u, and I put the negative 4 out front. Because it's, remember, we got to multiply the two results in the end. That's what the chain rule says. I've already bored Sean to death. Okay, flip it to the front. Here's all we have to do, and you're going to have the rest of the hour work. That's, we just have to do this example 1 right here. That's it. Maybe he's not cut out for the class. He might have to drop the class. Might need to drop the class. Okay. So it says, let g of x equal the integral from negative 6 to x of f of t dt, where this is f of t. This you will see on the AP exam. This is an excellent problem. It looks challenging. It's not that bad. We're just going to get started with evaluating different parts of it. We're going to look at g of negative 6. So g of negative 6 means negative 6 goes in for x. So we're going to look at the integral from negative 6 to negative 6. Remember, the integral represents the area bounded beneath the function between those two values. So the integral from negative 6 to negative 6, is there any area that you get there? There's no area. The height is 1, but there's no area. G of negative 4 means that integral bounded from negative 6 to negative 4. So now I'm looking from negative 6 over to negative 4. How much area is bounded there? 2 units. How about g of negative 2? It looks like I pick up this positive box there, but then I have another little bit of positive area and a little bit of negative area. Would you say that that positive and negative approximately cancel each other out? So I just pick up one more box of area. So I get 3. Now, g of 0, it looks like I'm going to pick up a lot more negative area, aren't I? Looks like I've got 1, 2, 3, 4, about 5. Can we all agree it's about 5 we pick up? So we're going to estimate we pick up about negative 5 units, so it's going to go down to negative 2. So g of 2, again, remember what we're doing. G of 2 is going to be the integral from negative 6 to 2. So we're looking at all the area that's accumulated here. We can pick up more positive or more negative. How many? Yeah, so we're down to negative 8. Then we're going to go to 4. Another negative. Another negative. It looks like this one maybe cancels each other out. Do you agree? So, I don't know. I picked up about negative 2 more. So that'll be negative 10. And then when I go to 6, am I picking up positive area, negative area? Positive area. 1, 2, 3, 4, 5. Sure, 6. We'll say 6. It's fine. Negative 4, approximately. Okay. So here's the question you're getting on the AP exam. It says, on what intervals is g of x increasing? Remember, the function is increasing when its derivative is positive, right? What's the derivative of the area function? The function. You guys agree that the derivative of the area function is the function right here? That's what we learned? So we're wondering, where is f positive? And that's where we pick up as soon as you get back, and we'll take about 2 minutes to be done. All right. Okay, so okay, all right. It's like Voldemort. Just what are the ghosts called in Harry Potter? Dementors. It's like there's like math dementors here. They're just sucking the heat and intelligence out of us. Just school in general. I know. It's like poor us. We have to go to school. You know, just like look at what they get to do in other countries. It's like, it's ridiculous. But yeah, you can be sent off to war or ostracized from your community. We have to go to school. So, all right, here we go. We'll stop complaining. All right, so on what intervals is g of x increasing? On what intervals is the area function increasing? We said that's wherever the derivative is positive. What's the derivative of the area function? The function. Where is this positive? Above the x-axis. Thank you, Wally. Where is it above the x-axis? Sure, negative infinity, negative 3. Negative 3.5, negative 2.5. I'm going to say negative 2.5, huh? Union with 3.5 to infinity. So where is it decreasing? That would be wherever f or g prime is negative, or wherever the function is negative. Think of it, folks. Is it collecting area or losing area here? Collecting. Is it collecting or losing area here? Losing. That's where it's decreasing. Does that make sense? Okay. All right. Where does g of x have a minimum value? You guys told me that the minimum happens where the derivative changes from. That's where g prime changes from negative to positive, or where f changes from negative to positive because f is the derivative of the area function. Where does f change from negative to positive? Yeah, 3.5. Sketch a rough graph of the area function or the antiderivative. Well, we just simply plot these points. At negative 6, I plot 0. At negative 4, plot 2. Negative 2, plot 3. 0, I plot negative 2. Something like that. Rough graph estimation, okay? So, two very classic types of problems that deal with fundamental theorem of calculus part 1. Be able to look at a graph and understand the relationship between the area function and the function. And then second of all, be able to look at integrals and recognizing if you take the derivative, you get the function. All right. Your assignment is at the bottom of your homework cover sheet. You have the rest of the hour today to work on that. You have work days on Monday and Tuesday. Work days on Monday and Tuesday. Kelsey has a question. Oh, never mind. You may go to the bathroom. Sam Chalmers is going to watch this video. Anybody want to say, give a shout out to Sam Chalmers? No? Wow. Wally says you need to score some goals. I think that that's a little... Oh, Kelsey says good luck in your 4 games next week. K. Alib says... I don't know if I should say that. Okay, you're a bender in hockey terms. I never knew what your newfangled language is, K. Alib. You're kind of a hip dude, aren't you? You want me to do mathematics? You want me to... Sam Earhart? Oh, boy. D. Weiland. Let's keep it clean, dude, okay? Ooh. Dylan, here's the deal. Dylan wishes he could be you, Sam. He wishes he could be you.